All right, as we start this new chapter here, we are looking at something called conic section. So here's the first day of your notes if you're looking at this. What we're going to do today is parabolas. So let me go back a second here. Take a look at this. Conic sections are pieces of a cone. So you see here there's cones, and the first shape that we are going to look at is something that we know that we've worked with before, but they're parabolas. We will move on and we'll do circles. So if you slice it, the way that this picture is showing, you'll have a circle. If you kind of slant it, you'll have an ellipse, and then something maybe you haven't heard of in this last picture is a hyperbola. So kind of cool, something to get excited about. Today we're just going to do parabolas though. So if you look at the very first formula here, it should maybe look kind of different. Maybe parts of it look familiar, but it is a little bit different looking. Notice we still have this h with the x, and we have the k with the y, and that was part of the parabola that we maybe remember working with the vertex is hk. So anyway, these parabolas are the ones that are going to open either up or they're going to open down. So that's what we're going to talk about first. When do they open up? When do they open down? We used to always talk about A. We don't have A anymore. We have this new thing right here, 4P. I don't care about the 4 right now. I'm just going to look at the P. So if the P is positive, it's going to open up. So the fancy way to say P is positive is P is greater than 0. If you would like to just write positive on your notes, go for it. If that P is negative, the parabola is going to open down. And again, the fancy way to write negative is P is less than 0. All right, look at the other formula here. If you glance, it's going to look very, very similar, except notice here that we've got the y squared. Y is squared, where over here you had x squared. So we'll talk about this in a little bit here, but you've still got your h connected with your x, you've got your k connected with your y, and then again there's that 4p. So this might be something kind of new to us. We haven't really done this before, but these parabolas are going to open either to the right or to the left. So we're going to say it opens to the right when P is positive. And we're going to say that it opens to the left when P is negative. So if you notice, those P's always have a 4 with it, but they're connected to the variable, either the x or the y, that is not squared. That's very important, and that's going to help us in a little bit here. All right, moving on to our definition of parabolas. A parabola says, is a shape that has every point equidistant, that's the same distance, from the focus and the directrix. All right, so focus and directrix, those are new words. We haven't really worked with those words before, focus and directrix, but we will come back to those. All right, so our vertex. Vertex hopefully is something you guys remember working with back when we did all this, but the vertex is just the point where, we're going to say where the parabola begins, but remember this, like look down here. There's my lowest point. There's my highest point. We talked a lot about min and max earlier in the year, but that's our vertex. In our new parabolas that open left and right, we've got the point far on the left and far on the right. These points are found by using the variables h and k. Remember, h is right there connected with our x value, or over here, right there, connected with our x value. The k is with our y values. Notice over here on this equation that the h and the k are a little bit backwards, so we'll have to be careful when we do those. Okay, moving on to the focus. So the focus is something new that we really haven't worked with before. Maybe you've heard about it before, but it's a point that lies inside the parabola. So I'm going to make some foci here. There's a focus right here inside the parabola. There's a focus in the parabola, and there's a focus in the parabola. So they're points that are inside the parabola that are equidistant from a point on the parabola and the directrix. The directrix is just a line. I always like to say that lies outside the parabola. Some people like to say behind the parabola. Either way, here's the directrix for that parabola. Here's the directrix for this parabola. There's that directrix, and here's this directrix. So I usually make them dotted lines that lie outside the parabola. So then we're coming to P. P is that new variable that we were looking at here. P is just the distance. So it's going to be a variable that represents the distance. Oops, I can't spell. The distance, that's better, from the vertex to the focus, or from the focus to the directrix. So if we find that P value, it's going to help us come up with the focus, this point here, and our directrix, the line right here. And what I mean by that is the distance from the vertex to each of those are going to be the same. There's my congruent symbols. Let's try a couple examples. Alright, so if you take a look at our first example here, notice that this is a y squared. What I would say to do until you get more comfortable with this is just keep looking at your notes, look at the two formulas that you have, and you have the one on the right that was y minus k squared is equal to 4px minus h. Okay, so then this was that new one that's going to open either left or right. A good way to try to remember that is the variable that is not squared, x in this case, the x-axis goes left and right. So that tells me that it's going to open either to the left or to the right. I'm not going to know until I figure out what p is. Well, here's 4p right here. Here's where 4p should be. So 4p is equal to 16. Divide by 4 to solve for p. P is positive 4. Since it's positive values are to the right on the x-axis, so this is going to open to the right. It's going to look like something like that. These are not going to be perfect graphs, they're just going to be sketches. Okay, so we've got that. Next thing we need is the vertex. Now, the vertex is h, which is added to the x value. Notice there's nothing added there, so I'm going to put a 0. And then there's a k, which is always the term that's added or subtracted to the y value, and notice there's nothing there, so 0, 0. So there's my vertex right there. The focus. There's formulas we can try to remember and everything for this, but the easiest way is to look at p. P is positive 4. We know it's opening to the right. So I'm going to go from the vertex to the right 4 spots. And there's my focus. That ordered pair is at, it went over 4 up 0. Actually, now I can go ahead and just graph my parabola. I'm not going to do anything crazy fancy. I'm just going to make a parabola that opens to the right. Next, I need my directrix. Okay, so my directrix, again, is the same distance away from the vertex that the focus was. It's 4 away. So go 4 in the other direction. So here we go. We are 4 spaces away from the vertex. Since that line's going up and down, remember lines that go up and down cut through the x-axis here. So it's an x equals line, and that's x equals negative 4. Something kind of cool I want to point out here. The directrix is x equals. The vertex, notice that was a 0 and the x value changed in the focus. Also notice here that the x value, or the x variable, is the one that is not squared. I think it's kind of cool. Alright, the other thing we need is the axis of symmetry. So the axis of symmetry, again, is something that we did back when we did parabolas. It's the line that cuts a parabola in half. So since this line is going left and right, cutting through the y-axis, this is a y equals variable. The y coordinate from their vertex is 0, so that's y equals 0. Alright, let's try another one. Take a look at example 1b. notice here that this formula right here has an x squared in it. So if I look at my notes, I notice that I've got x minus h squared, the formula on the left, is equal to 4p y minus k. Alright, and I notice also that my formula, or my equation, doesn't look anything like that. First of all, I have something in front of x squared that I want to get rid of. So that's a 1/8. I'm going to go through and multiply everything by 8 to get rid of that. Those cancel out. I'm left with x squared plus 8y is equal to 8 times 0 is 0. Alright, again, I want the x squared to really be by itself. I want to isolate it, so I need to get this 8y over. So I need to subtract 8y from both sides. So here's my formula. X squared is equal to negative 8y. Alright, now I need to know which way it opens. So my trick before was look at the letter that is not squared. It's a y. Y's go up and down. So that means that this parabola will open up or down. I'm going to find out which direction by finding p. So there's that negative 8 is where 4p should be, so I'm going to write 4p is equal to negative 8, divide by 4, p is negative 2. It's a negative. Remember, negative y values go down, so this parabola should open, or will open, down. Okay, vertex. Again, nothing is added to the x, nothing is added to the y, so the vertex here is at 0, 0. Focus. We're going to find the focus by using this p-value. That's a negative 2. Remember, it's opening down, so I want to go down 2 spaces. There's where my focus is. That ordered pair went over 0, down 2. Actually, now I can go ahead and just graph my parabola. There we go. My directrix, the directrix, is also 2 away from the vertex, so but this time I've got to go up 2. And once I get there, make my line. I usually just make them dotted. Sometimes they won't look dotted, but so that directrix is cutting through the y-axis, so it's a y equals line, y equals 2. Again, remember my cool thing I said? If the directrix is a y equals, notice in the vertex the y value is what changed. And in the original formula, y is the variable that is not squared. I think it's cool. Lastly, axis of symmetry is the line that cuts a parabola in half. This line's going up and down. This is an x equals 0 line. Very cool.